that was kind of dumb. So one of the first learnings from back then was that branching can hurt. You do branching for release and for good reasons sometimes, but back then, the simplest thing to do, especially with the tools we had at the time, was to work in a single branch. And if everybody can do that and commit frequently because you're trying to bring everyone's code together, not let it sort of, splay apart for months at a time, then you had a good chance of delivering your project on time with no surprises at the end. And I guess the important thing about continuous integration is it's just a process. It's what people do. So there is no need for amazing amounts of tools. You need a spare workstation in the corner just to make sure that your 90s source control tools actually got all your changes. You go to the workstation in the corner, run the build, make sure all the tests pass. You did write unit tests, right? And we had those in the 90s too. And that would just kind of work. Someone else would have their turn to push. Oh, the one piece of equipment you needed back then was a rubber chicken. If you pass a rubber chicken around the building to see if someone's going to be pushing to the trunk, then it's fine. The holder of the chicken can do that. Pass the chicken on to the next person. But of course, we're developers. We like tools. We like making tools. And so by 98 or so, we had Mozilla Tinderbox. And this was, I think, the first example of a CI/CD server, a CI server that we found. Mozilla did that. You can see in the URL that they're working on the SeaMonkey code base, which I kind of recognize. And you can see that someone called Blizzard broke the build on Mac OS X. Also, the font choices are kind of disturbing for the time. But then we got to cruise control a few years later. Cruise control was originally a Java app, though it was ported to C# and Ruby. You can see here it is phenomenally ugly. The UI was terrible, and I'm sure if they'd actually done a better UI, people wouldn't have hated on it so much, but it did actually do the job in helping teams build. And you can see here we're running CVS, which takes you back a wee way. And this is when I entered the build and release kind of field. My day job was mostly just wrangling cruise control and the related builds and release processes. So good times. And then things got a bit better around 2006 or thereabouts. This is Team City from the JetBrains editor people, and they had beautiful integrations. This was one of the few tools that would actually tell you, that would actually tell you you had broken the build before the build finished, and that was again quite an innovation for the time. Honourable mention also to Hudson, which became Jenkins, which is still in use today. They all kind of made continuous integration sort of move forward, be a better experience, and give developers feedback so they could do a better job. So all that's wonderful. So that's continuous integration. We need to explain the acronyms a bit further. And so shortly after that, ThoughtWorks came out with the very first tool that would attempt to take code from a repository of some kind, gets a version, whatever, and then deploy it all the way into production. And that's really the genesis of what we call CI/CD now. Back in the day, when the continuous integration book came out in 2010, they described it as a deployment pipeline. Automated manifestation of your process for getting your software from version control into the hands of your users. And you can see a diagram in a moment, but you're building the software, following the progress of those builds through multiple stages of testing and deployment. So you're taking your entire life cycle of software and squishing it into a minute copy of that. And you can see that here. There's the delivery team here. They are pushing into version control. We're building in unit testing. We've got automated acceptance tests. We've got a space for manual acceptance testing. And then finally, once you've beaten the snot out of this code to prove that it's actually viable, it gets into production. And that's the whole point. When Jez Humble used to talk about continuous delivery back in the day, he would describe it as a Herculean journey that your release candidates had to take to actually be worthy of production. Though he studied the classics, wasn't able to give examples of Herculean journeys, and I didn't. So really, continuous delivery is really CI/CD. It's a superset of CI. And it's attempting to bake a lot of practices from ThoughtWorks' delivery into one kind of how-to book, which is still kind of relevant today, though it's quite a long book. Maybe get the Cliff's Notes or something. Anyway, we're nearly at the present day, and we can see we now have tools like Buildkite, which is an excellent CI/CD pipeline tool. What I like about Buildkite is you can run your own agents. So you can run your own runners and have control over what's going on there, but they take care of the nice shiny UI and all the integrations and connect it up to everything. However, what we do for our projects is mostly Azure DevOps. So I had done this anyway. This is an example CI/CD pipeline in Azure DevOps. We ended up talking to people about how to bake security into CI/CD pipelines, and sometimes there's kind of a variance in people's expectations. So I've just put this together. So this is a multi-stage pipeline. You can see that at the first part, we're all about validating that code. We build something. We deploy it to a test environment. We run some acceptance tests. We run a Zap scan on it, and we do the same thing over production. So we've got several distinct phases of delivery and value here. And obviously, this is the overall pipeline design, and we'll come into some more detail there. I think what's also super relevant is that it's a YAML file in a GitHub repo. The pipelines and the code are so tightly coupled that you generally want to have a YAML file to represent everything. And when you change the YAML file and you change the code, you want all those changes to go out in lockstep. So you can't really see it here, but it's YAML, and that's a good thing. And it's kind of timely that we're doing this talk. This is the second or third time in other people's talks that they've mentioned the CI/CD top 10 these last couple of days, and then last month the government said, yeah, you should look out for your CI/CD systems because they are getting owned, and you know that's their kind of publication out there. How are we doing on time? So, 15. Okay. We are going to pick up the pace a little bit. We're going to have some Gatorade. So let's talk about the CI/CD top 10. So here they are. Unsurprisingly, there's 10 of them. So I guess the context for this is that CI/CD in 20 years has come of age. And yeah, our attackers have also matured an awful lot at the same time of our tools. So the first KiwiCon I went to in 2015, one of the speakers said Jenkins servers are a free pass to taking over production. That's still true now, or any other CI/CD server. And we've already seen these breaches in the wild. So, you know, SolarWinds obviously, but others, quite a few others. So thanks to Daniel Krivlich and McGill at Cybersecurity for putting this together. It's a proper OWASP project and everything. And from here on, I'm going to talk about the risks that identify in this taxonomy, some of the controls you can have, and then examples for the first 5 anyway. So, insufficient flow control mechanisms is the first one. You probably heard me swallow, sorry. So, the whole point of CI/CD is to improve flow and get software being yeeted from source into production. That can backfire on you as well. So if you have access to any parts of the CI/CD pipeline, you can potentially inject malware or badness. So, you know, anything to do with code pushing into production, pull requests being merged, artifacts, anything, they all cause potential issues. So it kind of applies everywhere. But we can put in controls. And so branch protection rules in CI, if you don't have those in a repo, strongly suggest you go have a look at that this afternoon. Also, auto-merging of pull requests is incredibly convenient, but also incredibly dangerous in the wrong hands. You want to have reviews into your pipeline so that people can't just fire their malware straight out. And also, because CI/CD systems rely on configuration, you want some drift detection for configuration. And so BadMe has sent a pull request to my example project and said, something, good practice, yeah. But when you look at the changes in that pull request, line 10 on the right-hand side, we're actually just deleting everything in my Docker file, so that's not helpful. When I pushed my pull request, it submitted it. The first thing I noticed was my vulnerability scanning GitHub action failed because it tried to remove half of the operating system, everything went wrong. But you can see here my pipeline. So this is one potential release candidate. It's stopped here. We've got building the app is skipped. And the reason why is because I knew I was going to do this, I stuck in a control. So there's a condition in my pipeline saying if you're not in the main branch and the previous build didn't pass, don't go there. And so it stopped. The other thing I've done is before you get to production, I've got to approve the production build. So there's a second control there to stop code getting in there. And if you're in any kind of SOC 2 or ISO kind of environment, well, you need to show that you've got approvals of releases anyway. So might as well just bake this in now. Annoy your development manager or someone every time you want to do a release, but then you can rely on that as a control for an audit. The next risk is dependency chain abuse, and that's a big topic on its own. I think lots of this talk could be a half-hour talk on itself. So we have dependency confusion, where people make packages that pretend to be your own or someone else's. Hijacking, where they completely compromise a package. Typo squatting, where they rely on people's spelling mistakes to get the wrong package. Brand jacking, where you plaster someone else's brand over it so it looks credible. And yeah, I don't know if people are caught up with manifest confusion, but it's just terrible. You look at a package, you look at its GitHub repo, and cool, it's got a package JSON, and it's completely not what you're going to get with the package. That one will run and run. So for controls, you're probably going to need to use a dependency manager like JFrog or Azure Artifacts or something, just so that all your developers are getting their packages from the same place and you have some audit log possible. You can also ban packages through a mechanism like that as well. If you have your own packages that have their own dependencies for what you need, I think that's a lot better than expecting your developers just to pull in what they need all the time. You probably need some kind of checksums. And you can scope packages in some package registries to make it very clear that this belongs to your organization and not random other places. And you can see here, I've run npm CI. If you do that in your pipeline instead of npm build, that will be very discerning about what it actually pulls in and what it doesn't. So, and it will actually fail the build if some of the packages change underneath you. And there is also this npm doctor command. You can see my laptop is not a pristine CI/CD environment. It actually looks a bit rubbish. And if you look at the end here, npm doctor also returned a non-zero return code. So if you bake that into a pipeline, it would just break your pipeline saying, wait, this is not a good environment. Don't carry on. You can also see npm scopes. You can claim my company, and then your developers can have some more confidence that they're actually bringing in packages that are appropriate. The next one is poison pipeline execution. I'm doing these out of order, by the way, because some of these are nicely detailed enough to go into. Thank you. Some of these are kind of normal controls. So even if you don't have access to the pipeline, you can still break things. So if you have access to code, you can change config files for CI, CD tools, the commit or a pull request. You can also compromise the ecosystem around a pipeline to break things. And if you're building in public, well, yeah, there's all sorts of things that can go wrong there. Though it's a very satisfying thing to do for open source to build it in public, but yeah, it can go wrong. So the controls, you really need to be careful about the nodes or agents or runner machines that that code is running on. So this is a fine place to use other people's, like Microsoft or GitHub runners for untrusted code. Just don't run it on your machines that can do other things. Don't build from forks, ideally, for public code. Branch protection rules come up again. There's another reason to look at those this afternoon. And if you have pipeline configuration and repos that are exposed to the public, well, yeah, try not to do that where possible. And then obvious things like, yeah, everyone wants access to your source control system, but you should probably be very careful and review access a lot, and then look what pipelines have access to do. And so here's some examples. For GitHub Actions, you can tailor what actions can actually do against a repo. You can also control behavior based on forks of your public repo. And here's a branch protection rule here, which is saying, okay, you've got to have a pull request before you merge. There must be approvals. And right at the bottom here is this line that says require status checks. That means that if your build breaks, you can't merge it, which is absolutely great. You should be having your pull request builds running cleanly. Next up, insufficient pipeline based access controls. Because pipelines look nice and abstract and, you know, you can see them visualized, it doesn't mean they're not running somewhere on someone's computer. And those computers can do all sorts of things in pipelines typically, like connect to your database or deploy applications to production systems. And so threat modeling is your friend here. And so basically, grant each pipeline access to resources and be really brutal about what it can do. Just because that pipeline over there gets access to your dev server or to your production servers doesn't mean this other one does. And it includes the nodes that everything's running on, because once you get onto those pipeline nodes, you get an awful lot of places in an organization. And in Azure DevOps, you can put a bunch of great checks in right throughout the system, and we've never seen those sort of proactively put in. Here's an example of one of those checks. You can't access this production environment that I made unless you're in business hours, so at least you get to sleep at night. The cool thing is that I made that in Terraform, and you can do a lot of configuration for Azure DevOps in Terraform, and then you have some protection against configuration drift as well if someone tries to turn off these controls because they're getting in the way of their day job. Honourable mention also to Sana Oshika from Pulse Security, who's identified that if you can run a pipeline and pass a parameter to it, you can probably take it over, and Microsoft weren't planning to do much about that. That's just, if you're accepting external data, you have to validate it yourself. I know we're racing through these. But the next one is artifact integrity validation. So SolarWinds. This is what happened with SolarWinds. And I hear that CISO is having a very bad time right now. So if you can inject artifacts or alter artifacts, you can get a payload and you can cause horrendous amounts of damage, as we've seen. The controls for that is pretty much signing everything. If you sign your commits, if you can sign the artifacts that you get out of your system, if you can manage configuration drift, then you can kind of get a sense of a chain of custody of your of the work and see that the artifacts being built are actually what you intended to be built. And third-party resources as well are always need looking at, which we'll cover a bit later as well. And so if I had the right Azure subscription, I could actually add signing to my example pipeline. I didn't have that ready for the presentation, but it's an option. And you can also do that in other container registries, like that's Docker Hub. You can, where it has these green squiggles, you can sign those tags so that you're absolutely clear on what you're going to get. So the rest of these 5 controls out of the 5 risks out of the top 10, they're kind of normal things we should be doing. Thank you for security anyway. So IAM is scattered everywhere. CI/CDs are like a poorly behaved octopus connecting to your systems. You need to manage the access control there. typically, we're stressed out about delivering, and we don't get around to doing that. And the kind of identities we end up with in CI/CD, like the local, they're stale. It's bad. So credential hygiene as well. They always end up in source. Always. Stop doing that. You should also think about, if you're growing credentials for one thing, don't let other things have access to it as well. Make new credentials. And in containers especially, you can put credentials into a container, you can override a new layer and think that they're gone, but no, they're not gone. They're just waiting to be mined out by someone who has access to your container images. And you should rotate credentials like we do everywhere else. System configuration as well. I've been put through the mill from a compliance point of view for CIS compliance on my production images, but never any pipeline images. You've got to patch them, access control to networks. It's convenient to have root access on your containers to get all the dependencies you need, but then that also helps you do all sorts of other things. You should have logging, the usual kind of controls we put in, right? And credential hygiene, obviously. Third-party services are a real challenge because, I'm pretty sure if you have a team of developers on a project, they can sign up for new services faster than you can review those and decide how to implement controls. And code analysis tools like CodeCov, which caused a pretty big breach a couple of years ago, are right out there. And they're valuable tools for the most part. And so, you can easily be attacked by their own tools. And finally, your logging and visibility. Dev tools. We don't need this as a dev tool until it isn't, and you're connecting to a production service, which is always the way these things grow. It always starts at the left-hand side and ends up in the right in a slightly odd shape. So if you're not having a threat model and thinking about these compromises, then you probably don't have audit logs, metrics, and some kind of seam anomaly detection for what's going on. So really, just to summarize the main point of this talk, this is a great tool. It's right there on that URL. There's a GitHub repo. You can even, submit a pull request if you want to, make any changes to it. It's a really great thing, and I really enjoyed looking at how it could be used. I'm so close to being done. And roundabouts. We didn't talk about roundabouts. So the very first continuous delivery pipeline that I know of was at the Dixon's project in Hemel Hempstead in the UK. The bottom of this diagram is where I used to live. The top of this is where I had to get to across a major modern metropolis. It took about 2.5 hours. And all I really remember is that we had a 4-hour acceptance test build that they had to plumb into the rest of the CI builds. And so that was the very first time I've actually seen a productionized pipeline, multi-stage pipeline running. And Dave Farley, who was the tech lead on that, went on to write the continuous delivery book. He's got a great YouTube channel. You should follow it. And so I remember the canteen, the pipeline, and then a roundabout, which, if you look at it, is a roundabout, and it's made of other roundabouts. There are 6 roundabouts and one other roundabout, and I'd see that at the beginning of my day, I'd see that at the end of my day, and I'm scarred for life. So finally, YAML. Use YAML pipelines. Don't have release pipelines that are a separate thing. It's all one thing these days. Everyone owns the delivery to production, so make nice YAML pipelines, keep them valid, and teach your developers about the threats because they've got as much skin in the game as you. Thanks very much.